This is the best use of polar coordinates. So in this video, we will solve this integral, and this integral will be immensely easy when we use polar coordinates. Yeah, and you might already see that because here's x square plus y square. That's the reason. Okay, so now if you want to change the polar coordinates, so basically x equals to r cos theta, yeah, and y is equals to r sin theta. That's why x square plus y square will just be r square. And if you use Jacobian matrix, Jacobian determinant, you will get that dx dy is just r dr d theta. And now regarding limits, over here x and y are going from 0 minus infinity to infinity. So basically x is also going from minus infinity to infinity, y is also from minus infinity to infinity. So basically all of our like Cartesian plane is covered, yeah. And to cover the same area using polar coordinates, we need to have like r going from 0 to infinity, yeah. And for every dr, our theta should go from 0 to 2 pi, yeah. Every dr should go from 0 to 2 pi. Similarly, this is one of the drs, and another dr over here, yeah. From 0 to infinity, we will have many such drs. Also another dr also going from 0 to 2 pi. So if it goes in the same way, so we will basically cover this ring, yeah, and then the ring after that, and then the ring after that, and then the ring after that. So eventually we will cover the entire plane. So that's how we determine the limit for polar coordinates, yeah. Now let's go to solve the problem. So basically, now if we enter the polar coordinate system, our theta will go from 0 to 2 pi, as I already saw that here, and radius from 0 to infinity, yeah. And you can also see this because we have r as square root of x square plus y square, so r will always be positive, yeah. And we have 1 by 1 plus, this is just r square, and then to the power n dx dy. Okay, sorry, no, not dx dy, r dr d theta, yeah. Now the next step will be integral from 0 to 2 pi. 1 to the power n is just 1, and this can be written as 1 by 2 can be written in front of the integral, and then 2r over here, and 1 plus r square to the power n dr d theta. Now the derivative of 1 plus r square is just 2r dr, so that's why this can be written as 1 by 2 integral from 0 to pi of 1 plus r square. And also note that our n over here is a natural number and is greater than 1, yeah. So that's why we will be able to use the formula, yeah. Because if it was 1, we need to use logarithms, but because n is greater than 1, we don't need to use logarithms. And the other formula, yeah, the other formula for this is x to the power minus n plus 1 by minus n plus 1, this one, plus c. And this plus 1 is basically in the exponent, yeah. Okay, now we'll use that. So this is minus n plus 1 by minus n plus 1, and it's going from 0 to infinity, and then d theta, yeah. And now since our n is greater than 1, so minus n plus 1 is going to be negative, yeah. N is greater than 1, so minus n is of course less than minus 1, and minus n plus 1 is less than 0. This is negative. And if r is infinity, infinity to the power of negative numbers will be 0, yeah. So you need to consider that fact, 0. And minus at 0, this will just be 1, and 1 to power anything is just 1, and over here it's minus n plus 1 d theta. So we have, now this constant, we can take out the constant, 1 by 2 times 1 by, and multiply minus sign, n minus 1, and this will just be theta from 0 to 2 pi. Yeah, so we have 1 by n minus 1 times 1 by 2 times, this is just 2 pi minus 0. So the answer will be 2 cancels out, and that's why we have pi by n minus 1, where n belongs to natural number and n is greater than 1. That's the answer. So this is the answer, and hope you enjoyed the solution. Yeah, and this problem was specifically made really easy by the use of polar coordinates. Otherwise it could have been tougher without polar coordinates. And hope you enjoyed the video. Thanks for watching and look forward to seeing you in the upcoming videos too.